Thank you everyone for making time today to attend our webcast, Creating Knowledge Workers for the Greener Product Marketplace. This is the 11th installment of this webcast series that we started in 2014. And we've had close to 30 educators from across the country and even from outside North America talk about integrating environmental sustainability into their curriculum. And the reason that we named the series Creating Knowledge Workers for the Greener Product Marketplace is ultimately it's all about creating jobs and driving our economy in the right direction. And schools will attract students who care about this and to meet the industry demand. And manufacturers will recruit students out of these schools who can execute. So what you're going to see today with our special guests, Thomas and Neethi, each of them are educating knowledge workers at different points in their education and in their career. I'm very excited to have Thomas from Yale talking about their distance learning and graduate course for executives and how Thomas is teaching lifecycle assessment and environmental sustainability using sustainable minds in a very different way than Neethi is using sustainable minds in her undergraduate engineering course. And so today you're going to see two very different types of curriculum being taught to very different types of students with ultimately the same educational goals. I'm going to start out by giving you an introduction to Sustainable Minds and a quick overview of our Eco-concept and LCA software so you understand how the software works. And then we'll move into the two presentations. First Thomas, followed by Neethi. They'll do their own introductions. And then we'll have some discussion between us collectively, as well as questions that you send in. And I'm going to imagine that most of you attending today have attended webinars before, but all you need to do is add your questions to the questions panel in the control panel, and we'll be monitoring those and answering those at the end. And if for some reason there's a question you've asked and we don't get to it, we will be sure to follow up and get that question answered. So without further ado, we are pretty excited to be able to claim many, many different kinds of manufacturing and educational customers using Sustainable Minds in different ways, but again, in support of the same goals of understanding the impacts of products across the life cycle and how those practitioners using Sustainable Minds or those students can understand where those impacts are occurring and make changes to make meaningful improvements to the environmental performance of those products. And Sustainable Minds is a business tool created for business users, but because of its understandability and ease of use, it's been adopted in education in every type of curriculum all around the world. Undergraduate business, graduate business, every kind of engineering, chemical, environmental, civil, mechanical, industrial design, and now even architecture. Our mission as a company is to operationalize environmental performance into mainstream product development and manufacturing for the purpose of for the manufacturer to drive revenue and growth through greener product innovation. To do that, you have to do two things, and this is what we've combined in our software, two fields of science and endeavor. The first being eco-design or life cycle thinking, and the second being life cycle assessment. People need to think differently and be able to think differently about a problem Eco-design is teaching life cycle thinking, so to think about a product in terms of its full life cycle. And then life cycle assessment is measuring. And when you do both together, you get truly greener products. You can't just think differently and hope that you're making changes that get meaningful improvements without measuring. And you can't just measure without thinking differently or looking at all stages of the product's life cycle. You're only going to get incremental improvements as opposed to innovation or exponential improvements. So you really have to do both. And that's what we teach and what we've embedded into Sustainable Minds. Innovation happens when people think differently. You have to measure to validate those ideas, and you'll get a credibly greener result. So the word greener is really code for environmental performance. And environmental performance is just a new criteria in product development that sits alongside functional performance, cost, aesthetics, safety, the whole litany of traditional criteria used in product development. And now environmental performance is just one of those criteria. And manufacturers have methods and tools and frameworks to be able to make trade-off decisions between those existing capabilities or metrics. They don't have tools or frameworks or knowledge to integrate environmental performance and be able to make informed trade-offs on that criteria. That's the problem that we set out to solve. And there are real business drivers creating real market demand for products with better environmental performance, from the cost and competition for natural resources, regulation, supply chain risk, the desire to build a more credibly greener brand, and certainly to create innovative new products that lead to new revenue and new customers. So we believe that environmental performance is an innovation driver that should lower costs and increase revenues. And ultimately, manufacturers operationalizing and making environmental performance a goal in all products will achieve a competitive advantage. And to do so, obviously, requires new knowledge, processes, and tools. So to shift to an environmentally sustainable design process, lifecycle thinking has to be adopted and incorporated during conceptual design. And so the full life cycle of a product starts with raw material acquisition to material manufacture to product manufacture. There's transportation and distribution between all of those life cycle stages, even between manufacture and use. And following use, we have different aspects of end of life, recycling, or landfill. And these are all of the stages of a product's life cycle that need to be considered by a manufacturer. And the reason it's critical to consider these life cycle stages in early stage concept design is that 75% of the manufacturing costs are committed by the end of concept design, and only 25% of the costs are determined later. It turns out that those decisions that get made in concept design, material choices, energy requirements, recyclability, the product lifetime, all of these choices lock in the environmental performance. So it's the same set of decisions. And once we get out of concept design into detailed design, it's much more expensive to make changes later, once the manufacturer knows what they're already making. So the ability to be able to make informed decisions early on is critical. Now, eco-design is the activity of looking at strategies that can be applied to each stage of the product's life cycle to drive new ideas to improve the environmental performance. We add this set of strategies prior to raw material extraction, the very beginning of the life cycle, which is innovation, getting people to rethink how the benefit might be provided, thinking about product service systems, really rethinking the product itself, and then looking at where in the life cycle are the greatest impacts, applying different strategies and even multiple strategies to drive those improvements. Lifecycle assessment is the internationally recognized method, scientific method for measuring the impacts of products and systems, and this is the standard process for lifecycle assessment. There are 3 stages: goal and scope, inventory analysis, and impact assessment. And because it's a process and a scientific method of discovery, there's interpretation and iteration between all of these stages. So Sustainable Minds software is based on these 3 stages and provides for that interpretation. And as a result, our software is ISO 14040 compliant. Now, this is probably the most technical slide in the whole deck. And it's how we explain simply how materials, or the term that we've coined, a system bill of materials, can be turned into environmental impacts. We coined the term system bill of materials because we've brought together 2 fields, life cycle assessment and product manufacturing. So we've merged terminology, bill of materials and product system. And so if you look at every single thing that is an input into that product system across the life cycle, all of those inputs can be expressed in its chemical data, which is called process inventory or life cycle inventory data. And when that data is put through the lens of an assessment methodology, it can be attributed to 1 or more categories of impact, and each of those impact categories can be attributed to 1 or more types of damage, either to human health or to the built or natural environment. Now, the way that we've simplified life cycle assessment so that users of Sustainable Minds don't need to be chemists or life cycle scientists is we've created our single figure score methodology that in a glance allows any user to see the impacts per input in a single score. So the higher the impact score, the greater the impact; the lower, the lesser the impact. We look at these 10 impact categories identified by the Environmental Protection Agency and their Tracy methodology as the 10 impact categories important to be measured in North America. And we use a normalization and weighting schema developed by the folks at NIST. And we use publicly available data from EcoInvent and other public process inventory data sources. And our methodology is the recipe of bringing together these methods, these impact categories, and these data to create our single figure score. And we also pull out the carbon equivalent scores, which are measured in globally recognized carbon equivalents, which are all the global warming gases, not just carbon. And so there's 2 scores for each input, the impact factor score and the carbon equivalent score, that users can use to understand the impacts of each input. Now, it's important to keep in mind that there is no such thing as a green product. There's no such thing as green. All products use materials, they all create waste, they all use energy. Green is a relative value. So something can only be greener than something else. So on the Concepts tab in a project, we report the millipoint score and the carbon equivalent score, but this is a relative value. This is an absolute value. So what's most meaningful about the results is the percent improvement, up or down, the percent improvement or the percent that it's getting worse. And so Sustainable Minds is an eco-concept modeling with real-time LCA results solution that allows product teams and students, as you'll see, to explore concepts and understand how the changes that they make in real time are showing up as impacts across the product system. So Sustainable Minds has software, variable data, and knowledge in the Learning Center. It's the equivalent of about a 150-page textbook, so that access to that information, again, in real time. People can learn as they go. They can learn in the way that they best learn. And it's all about knowledge sharing. Bottom line, Sustainable Minds is about creating benchmarks, getting quantified estimates of those environmental performance for non-experts to standardized system and easy to share results. In the Learning Center, probably the largest section of the Learning Center is the user's guide that steps you through each step in using Sustainable Minds to go through an eco-design and LCA process. It has lots of examples, lots of illustration. Again, can be used as a textbook equivalent. And we have the option for adding data to the tool to help manufacturers and in education model with the data that you need. We'll add data from publicly available data sets at no cost. And part of our service is to create data, whether it's proxy data or primary data from manufacturers, to add that data as needed. We have a data browser that allows you to look through to see what data is in the data set. So at the beginning of a project, people can check and see, is the data that I'm going to need there? You can look at the data, the inputs by life cycle stage. I can look at materials, I can look at processes, use phase, inputs, end of life, transportation. And I can easily request data from this downloadable form if it's needed. And when the data is proprietary, like in this example for our customer Toto, that data can be in a private data set, otherwise it gets added to a public data set. We believe that innovation is risky, and so there has to be ways to measure ROI. This is critically important, obviously, in industry. And so there are cost savings as well as value creation, different ways to tell an ROI story in industry. And we have many, many case studies from industry and education. These are all on our website, either in webcast form or in customer story form, talking about how Sustainable Minds was used in the context of a project, who were the users, what problem was solved, what were the results, decisions made, the strategies that were used, and the key learnings. And you'll see in our guest presenters today that very same framework of storytelling. What was the problem? What were the results? Decisions, eco-design strategies, key learnings. You're going to hear those stories told by our two presenters. I'm just quickly clicking through an example project. This is a technical evaluation of data looking at a full life cycle of a product by a manufacturer who was looking at both the product and the packaging all in one project, so they could see what was causing the greatest impacts before digging into each piece. You can see it's easy to annotate the system bill of materials, again, for collaboration and knowledge sharing so that all the assumptions get captured. And by looking at both the total impacts and the carbon footprint, it enables users to make different kinds of decisions based on the performance goals set by the team and set by the company. So with that, I would like to introduce our first presenter, Thomas Kwan from Yale. And Thomas is going to tell us about how he's teaching with Sustainable Minds to executives. And Thomas, take it away.
All right, thank you very much, Terry, and good afternoon to everybody. As Terry said, my name is Thomas Kwan. I'm an NSF fellow at Yale University, and we are doing LCA design decisions for executives. So a little bit about me. There we go. I'm actually in the engineering department, and I develop sustainable technologies for nutraceutical, pharmaceutical, and biodiesel products. But I'm also a fellow with Yale University in that I work with other faculty members to do curriculum development, and I also teach a couple of classes. And one of the classes is for our School of Management. So I put a picture up here of our brand new school. It just opened up a couple years ago. I kind of think it looks like an airport, and it has certainly been mistaken for a mini airport as some guests drive along. But this is our new School of Management. It's Evans Hall, and this is where some of our class took place, in which we use Sustainable Minds. And our student base are MBA students, but they're not your typical MBA students. In fact, the program is called MBA for Executives. So our student base are working executives that are returning to school to seek their MBA, and they have a company endorsement to do so. It's a 2-year program in which the first year is kind of a set core class taught by our School of Management faculty, and our second year there are different classes in which other kind of experts from outside of their school teaches classes or co-teaches classes, and this is how I got involved, along with a couple other faculty from engineering and from chemistry, to do this class for the MBA students. And there's a few different focuses for this MBA for Executive programs. One is asset management, healthcare, and then sustainability. So naturally, this is where our class students want to focus their interest in, is in sustainability. So our class is called Sustainable Design and Innovation. And in this class, what we really wanted to do is have our students become aware and have a complete and full understanding of what a quote-unquote green product is, how to assess that, how to measure it, and also how to develop it. So certainly our student base is not the type of students that would traditionally be running real high-level life cycle assessments, but they are certainly the type of students that will eventually be presented with life cycle assessment results, and they will be, you know, people that will make decisions based on those results or make recommendations on different product designs and LCA results. So we wanted to give them a hands-on experiential learning in terms of thinking about design, assessing design, and how the environmental impact can be taken into account with that. So, excuse me, we had some of our class in the School of Management and some of our class in what is Yale Center for Engineering, Innovation, and Design, or we call it the CEID. This is essentially a makerspace, and if you're not familiar with a makerspace, in short, it is consolidated area for us that has 3D printers, it has woodworking machines, it has metalworking machines, it has sewing machines, so it has very high resolution equipment to prototype designs, and it also has very low resolution equipment like, you know, popsicle sticks and glue and sticky notes, essentially just to get people's ideas from paper all the way to product. So this is where some of our class also took place, and we'll talk about how we incorporated this space with their curriculum and how we incorporated sustainable design into it. So our goals for the class was for them to be able to design themselves and to assess sustainable products and to justify or invalidate different degrees of product sustainability. We really wanted them to understand how LCA information is generated and what kind of questions they should be asking when presented LCA results, environmental impact results. We wanted to give them a big picture on what it means. So to give them this experiential learning, we developed a couple of different case studies, which we contrived, we manufactured ourselves, and they went out and they used Sustainable Minds to do the LCA on, and they came back and were supposed to justify and recommend which decisions they should make, and we'll go through these. And then the third way we implemented Sustainable Minds in our class was a one-day, I guess you would call it a one-day incubator project in which we had them go into our makerspace, presented them a challenge, and asked them to develop a sustainable product and to prototype it in 1 day. So they use sustainable minds to justify sustainability and to get real measurements and metrics on what their design means in terms of environmental impact. So for our 3 different ways we incorporated sustainable minds in our curriculum, 2 was a case study and 1 was a hands-on project. So if you look at the upper right-hand corner, I numbered our different ways we implemented our LCA concepts into our curriculum. So this is the first way. This is the first introduction for them into LCAs and sustainable minds. So we had given them traditional lectures and information about LCAs, and most of them, they got the feeling like LCAs was just too big of a concept. It was too difficult to focus in and pull meaningful information out. Our way of addressing that was to get them to actually do LCAs themselves in a screening level manner. So the first contrived case study we had was about hospital gowns. And we asked them, we gave them, you know, some fabricated information, and they did the LCAs themselves, and they were supposed to provide a recommendation on which hospital gown they should recommend for the hospital to buy. So all of our students did this, and it was the first time they'd ever done an LCA, and they had to think about not only the actual results of the LCA, but also the context in which the LCA was performed. So the task here for our students was, 1, get their hands on the software, start pulling numbers, start to see how different things affect the impact results, but then also think about the products themselves in terms of functional performance. And as it turns out, the way we set up the project is the hospital gown that had the least environmental impact comparatively was in fact the worst functionally performing hospital gown. So we wrote a case study in such that this particular hospital gown would in fact be really uncomfortable for the doctors, and they had to infer this information, and that the doctors would not prefer this at all. They would prefer a lighter material, which is our second gown here. So our trick for them here was kind of twofold. 1, get in there, do the LCAs themselves, but bear in mind the bigger picture and the functional performance, so that the link here is sometimes green design gets you know, thought of, or there's a myth that green is bad or doesn't perform as well. So our twofold objective here is, 1, to have them think about green still must function at the same or better level than comparative products, and 2, to get their hands in on the LCA themselves. So our results for this first project was functional performance is absolutely critical. Context for the LCA results is necessary. They couldn't just go by the raw numbers that they got, or they would have missed the point on which hospital gown to recommend. And then for our students, they saw that they could jump into sustainable minds and start doing the LCAs relatively quickly. All right, for our second case study was similar in that we contrived a scenario in which there were 4 different toasters, and we asked them to recommend, you know, the most green one or the most sustainable one. But there was a few business twists in this, in such that there was a complex networks of firms, and that they had the power to leverage their position to have different firms work together. So we asked them to review the case study, do the LCAs of all the different concepts or designs, and then if they wanted to, if they thought it was necessary, to leverage their business position to have different firms combine their designs. So, excuse me. Before we started this, after they read the case study, we asked them, just by using your intuition, which design do you think would be the least environmental impact? And they kind of wrote like a 1-page justification on why they thought one design would be better than the other, just solely by using their intuition. We call this your sustainability intuition. And we had them do this because we fabricated this exercise in a manner where their intuition was most likely going to be wrong, and we wanted to highlight the importance of having real metrics, real measurements of environmental assessments. So here you can see it was a toaster, and they ran probably about 16 total LCAs of different combinations of the different designs, and recommended based on the environmental impact. So in fact, one of the designs had very little environmental impact, but met the company's goals in terms of how things were going to be explained to the public or used in terms of giving the public information about their sustainability practices. And so that firm was combined with firms that did more technical work to lower the environmental impact of their toasters. Our result is most likely your sustainability intuition is not going to be reliable. And hey, even in the few cases where maybe somebody's intuition is reliable, you still need real information, real data to analyze the results. And in this case, the transportation and manufacturing had the highest impact on our toasters. And again, this was a very contrived example for them to use the LCAs, but also to think, you know, in a bigger picture sense, to have them understand what these numbers mean and how it partakes into their business decisions. All right, so lastly, the final way we integrated sustainable minds into our class was having them go in and develop a product from scratch to prototype in a single day. And they had to justify sustainability. And we said you could do that in any way you would like. And of course, all of our students automatically jump to sustainable minds because they say, well, we need to have some real data, some real metrics here on what our designs are. So we asked them to redesign a hot teacup and then have a few different concepts or alternative designs, and then select one of their concepts and then justify it as the best. And then at the end, they gave a presentation to their peers and to their instructors, and they kind of got, as they say, they had to go through the fire of the peer review process at the end. Now, I don't have any particular results from this one-day incubator project, but I do have some pictures for you. So here we see our School of Management students in our makerspace starting their concept designs, mapping out their ideas, and building their prototypes. This was after they ran some initial information to justify sustainability using sustainable minds. So if you knew some of our students here, you would be absolutely ecstatic that they are actually prototyping something in our makerspace, because some of them just started this class with never having touched a screwdriver, never having touched a hammer, but by the end of this course they got some real experiential learning in terms of product design, justifying sustainability, and having their hands, you know, as they say, getting their hands dirty in the process. So in this particular case, for the hot teacups, the materials manufacturing and end of life had the highest impacts. But another result that our students took away was they understood that using the LCA information, kind of a screening level LCA, at the very beginning of the concept phase of design was critical. It was important. And in fact, for most of them, it helped catalyze their innovation. I kind of think about it as they saw it as a way to gamify their design, because they started to put information in on materials and ways they would design, and they would see their impacts comparatively were high, and they wanted to get those numbers low, so they gamified it. They would change materials appropriately, change different places where they could source the materials for transportation so that they could get that number down, and it really helped them innovate a new product. All right, so this is a curve just reiterating what Terry said at the very beginning. This is our cost committed versus our design product time frame, and our students really took away this idea that during the concept design phase, not only do you make decisions of cost, your cost impact throughout your product design life, but also the environmental impact is critical here at the beginning phase in terms of the concept design. All right, so some of our key takeaways For using LCAs and using sustainable mines in our class, for our students, they took a real understanding that functional performance is critical. Just because a product or process may score relatively better in terms of environmental impact, you really need to consider the function of that product as well. And so function is paramount, and we really drill that into our students. Eco-design and LCAs and product development is absolutely essential in today's modern society and way of doing things. We need to consider the environmental impact. So using these screening level LCAs and a low barrier to use sustainable mines, a low level entry, was easy for them to jump in and start using that. For educators, we're always thinking about design thinking and systems thinking, or you might call that sustainable thinking. So design thinking and systems thinking are easily bridged using sustainable minds and the LCA tools. For our student base, the executives, we gave them a hands-on experiential learning experience in terms of assessing products and designing products. Now, as I said at the beginning, our students are most likely not going to be the ones at the technical end of a life cycle assessment, but they will certainly be presented information from life cycle assessment. So this is their hands-on experience to really understand what the results mean and what kind of questions they could ask. It gave them real insight in terms of assessing an LCA. And with that,
thank you very much, Thomas. I can tell you really gave those students a run for their money, and the makerspace is an incredibly powerful experience to be hands-on, and I'm really happy you shared not only images of that, but showing folks actually making stuff, because a lot of times faculty will teach by using teardowns. So in a space
right.
like that, tearing something down,
Mm-hmm.
measuring, weighing, putting it back together. And so, getting your hands dirty, making stuff, touching real stuff in combination with using software tools is a very powerful learning experience. So thank you so much. And we'll actually have discussion and questions at the end. I want to move right along to Neethi and go right ahead and introduce yourself.
Thank you, Terry. And thank you, Thomas, for your presentation. I'm going to switch gears and talk about how we teach sustainable mines at NC State. My name is Neethi Rajagopalan. I'm a research associate in the Department of Forest Biomaterials at North Carolina State University. So today I'm going to talk to you a little bit about our experiences of teaching life cycle assessment and sustainable mines at NC State. Richard Venditti, he's also one of the instructors of the course here at NC State, and he's listed as one of the presenters, but I'm the one presenting. He's not presenting today. So just to give you a few points about my background, I have a PhD in civil engineering from the University of Pittsburgh. And for my PhD, I researched sustainability of green buildings and building products. After my PhD, I was a postdoctoral instructor at Duke for a few years. I taught LCA for master's students, professional master's students, before I moved to NC State as a research associate. So currently, I research sustainability of bio-based products, and I'm interested in sustainability to better understand and reduce my impact on the planet through my various activities. It's about the school. So we at North Carolina State, I'm in the Department of Forest Biomaterials. I've provided you a link if anybody is interested in learning more about the department. But it's a few key points. The department resides in the College of Natural Resources. The department has two programs. It's Paper Science and Engineering and Sustainable Materials and Technology. We have about 20 full-time faculty and more than 200 undergraduate students and 40 graduate students. And we also have a large network of alumni who, many of them who are now CEOs and senior executives in major pulp and paper or wood product companies. So our life cycle assessment course is mainly geared towards junior and senior level undergraduates and graduate students in the Forest Biomaterials Program. Other students in other departments who are interested to learn about life cycle assessment are also welcome to enroll in the course. We do have some prerequisites for the course, and if they've completed those prerequisites, they're welcome to join. So the course basically gives an overview of conducting an LCA of a product or a service. So students learn step by step how to create a goal and scope for the project, how to create an inventory, how to conduct an impact assessment, and we provide them methods to interpret their results. We follow a standard textbook in class, and we devote class time to help students understand the basic principles of life cycle assessment. So we follow this up with providing students assignments so that they can understand the concepts that they've learned in class and go through them and learn more about them individually. We also teach students the skills to communicate the results and also teach them how to critique their own work and the work of others. So as part of our teaching LCA, we introduced the students to various tools available to them. And last fall, we taught sustainable mines to our students in class. And before I go ahead with the project, I want to explain how we taught them sustainable mines. So initially, I gave a presentation in class about sustainable mines and showed students how to use the program step by step. And also pointed to the user's guide. I said that that was a really useful resource for them. And then the students had an in-class activity guided by me. So they followed along as I went through the activity, and they were able to use the program on their computers while I demonstrated on my computer. After that, the students then did another activity in class, but this was a group activity. So we divided the students up into groups of 3 or 4, and we had them do another class activity and made them use sustainable mines for that. And finally, we assigned homework assignments where they had to turn in their work individually. So essentially, what I want to show over here is that we gave them various opportunities to get comfortable with the program and comfortable with the concepts of LCA presented in sustainable mines. And so what I'm presenting over here is one example of the projects assigned to the students. So the project is named Sunglasses. And the goal was to understand the environmental impacts of a pair of sunglasses manufactured from different materials. So here we're using metal, wood, or plastic. So since we are a Forest Biomaterials department, almost all of our activities involve some kind of wood. So that's why wood in the sunglasses as well. So students were first required to design 3 pairs of sunglasses. So we gave them some client preferences, and they were asked to design 3 pairs of sunglasses. And then, based on the environmental impact of the sunglasses, they were asked to redesign a single pair. So we provided data on materials, manufacturing processes, transportation, and end-of-life information. So to give you a snapshot of what that looks like, this is what the homework assignment we assigned to the students looks like. So we told them what what the product was and who the client is. We gave them some information about the material and what processes they need to use and material quantities. We gave them transportation modes, transportation distances for each of those materials, and for the final assembled product. And we also gave them information about the end of life. So once they were given this information, the students were given some time to complete the assignment and turn in their work. So this is what some of the results look like. Again, this is from a student's work, and I've modified it for this presentation. So the student used metal sunglasses as the baseline pair, and these are results for that for the metal sunglasses. So if you see on the top left, you can see the environmental impacts by the bill of materials. As you can see, the blue, the solid blue, is the aluminum material which is used, and that had the highest impacts based on millipoints per functional unit. So the functional unit over here was 1 pair of sunglasses. And this was followed by the aircraft travel. Now, if you see on the top right, we can see the carbon footprint. The carbon footprint, the aluminum again had a high carbon footprint, but you can see now the aircraft travel has also increased. So in the carbon footprint, because in the previous slide I showed you that we provided transportation distances, and some of the transportation distances were pretty high, so it was no surprise that the carbon footprint of aircraft was high as well. Now, if you see on the bottom left, you can see that the manufacturing stage had the highest impact by life cycle stage. Again, you don't see use over here because we did not account for the use of sunglasses. So when you see the bottom right, again, it was no surprise to me that manufacturing had the highest carbon footprint by life cycle stage. But again, transportation also played a significant role in the carbon stage. So in the next slide, again, these results are modified. So this slide shows the comparative scorecard of metal versus with sunglasses. And this, the scorecard feature was a major hit with our students. They really liked this. So the metal sunglasses had a high environmental impact in the carcinogens category. So that is the black hatched line on the left. And this was followed by global warming, which is the blue hatch, and the fossil fuel depletion is the solid blue. If you look at the right image on the right, you can see that global warming plays a significant role, followed by fossil fuel depletion and carcinogens. So the student decided to modify the metal sunglasses because she felt that that had the highest impact. And so the first thing she did was she increased the service life to 10 years from 1 year. And this, she said, this improved the environmental performance by 50%. So that was a significant environmental improvement in environmental performance. The next thing she did was she changed the aluminum material from primary, which is that it had no recycled content in it, to 100% recycled material. Now, this improved the performance drastically by 80%. But again, this made aircraft travel as the highest impact category. The third modification which was made was to use glass manufactured locally and transported locally. Now, this maintained the performance at 80%, but aluminum again became the highest impact. So again, this was just one example from one student in the class. I'm trying to, yep. So some of the key learnings for from the student side we felt was that the students learned the basics of creating a product LCA in sustainable mines. They learned the value of initial product design and then redesign based on environmental preferences and environmental performance of the product. And the most important thing, they understood the complexities of conducting an LCA and the importance of communicating LCA results in a manner which can be easily understood by the general public. So that, I think, was a key learning point for the students. Some of the key learning points for educators, she felt, was that sustainable mines is an easy, user-friendly approach to teach LCA. And teaching sustainable mines gives students a snapshot of the various tools and data available to them to conduct an LCA. But one of the biggest advantage we felt for using sustainable mines was that it is a cheap option for students to get acquainted with and comfortable with conducting an LCA. And that, I think, was a major selling point with students as well. So what we see as trends in sustainable mines helping prepare students. So as companies are starting to become more and more environmentally conscious, students are learning the value of using LCA in their careers. And we feel that sustainable mines provides them an avenue to easily explore product LCAs, understand different environmental impacts, and play around and see how they can reduce environmental impacts of their products. So they can go in and change some parameters and reduce the environmental impacts, just like I showed before. And that, I feel, is important as students are learning LCA. And some of the industry takeaways we feel is that students in our department, in the Forest Biomaterials department, after they finish finish studying over here, they go to work in traditional pulp and paper mills, furniture, or wood industry. So these are traditional industries. However, the wood products program in our department has recently been changed to Sustainable Materials and Technology program. And we've included LCA and other sustainability courses to the curriculum, mainly because students are asking for these kinds of courses. So the key takeaway, or the key takeaway which we want to say, is that learning LCA and the use of tools like sustainable mines engages students, and this trend is here to stay. And making LCA as part of the core curriculum will encourage more systems and life cycle thinking as students prepare to start new careers. And they will be more ready to go into the sustainable workforce after learning life cycle assessment and other sustainability-related courses. So that's all I have, and I'm open for questions. Thank you.
Thank you so much, Neethi. That was a wonderful presentation, and I think a fantastic contrast to the story that Thomas told. But at the end of the day, just to segue out of your presentation, it is all about jobs and the economy. Just like Neethi pointed out, students are asking for this kind of curriculum. We've had many examples where educators have told us that the registration in their department has gone up substantially, registration in courses. They are attracting more and better students. And what's super interesting, Neethi, this is another example. We've had this happen a number of times too, where educators have reported that their programs, their departments are being reframed and even retitled to include environmental sustainability for that very reason, to change up the curriculum, attract students, because schools are businesses just like anyone else, and everyone is looking for a job. And being able to take these skills out of school into the workplace is critical. People do and should put sustainable minds on their resume. Understanding LCA, eco-design, sustainable minds is a tool. It's something that educators look for. And now I'm going to answer a handful of questions all at once because people are ready to understand the tactics. Yes, Sustainable Minds is a cloud-based solution. It is affordably priced for education. You can start with a free 7-day trial. All you have to do is go to our site, go to the Sign Up Now button. You can start a free trial. The educational pricing is substantially, dramatically less than the business pricing, and there's no difference. Everybody gets the same tool. There is no educational version. Everybody gets the same tool. So the cost is $350 a year for each educator and $49 for 6 months for each student. Now we have quantity discount programs to encourage programs to have one or more faculty teaching. Schools buy packages for multiple courses, for departments, even for entire schools. We do also offer support packages, custom data, and some training. We have a curriculum library that if folks are looking for ideas of what to teach or how to teach, we have some example curriculum. And the thing that we're extremely proud of is this webcast series. And actually, I gave you the wrong date. The first one was in 2012. And so our 11th installment, we usually have at least 2 a year. And we are really, really psyched to have had Neethi and Thomas today sharing the stories that they've shared. And I'd like to just ask for a little bit of discussion. Neethi and or Thomas, do you have questions or feedback about each other's courses? Kind of thinking about what might other people be asking that they haven't necessarily asked or would want to hear some feedback on.
So, Thomas, I actually really like the maker space idea. Mm-hmm. And so you said that your students actually went about and created. So did they create actual products and then use sustainable minds to evaluate sustainability and then go back and change some material properties to see what the environmental impact reduction would look like? Is that what they did?
Yeah, so the answer is yes and yes. So they use sustainable minds in their concept design, basically as they were mapping out ideas on paper and putting what's in their head down and communicating it to their teammates. They were using sustainable minds to assess what kind of impact they might be incurring with their product. From there, we asked them to have at least 3 different concepts, and then to choose one to move forward with before they actually started prototyping. As they were prototyping, they were still going back to sustainable minds to say, hey, well, if we got rid of this O-ring and changed it with this material, or if we changed the geometry of this cup, so we use less material, they started to incorporate the life cycle thinking as they were prototyping. So they used it both prior to actually having anything physically in their hands, but also as they were going forward in the day prototyping, they were still going back to it to see if they could tweak for better environmental performance.
So the question which I actually wanted to ask was, so are the backgrounds of students really varied? As in, do they come from like engineering backgrounds or science backgrounds or arts backgrounds? And did they have difficulty in understanding or using sustainable mines, or was the learning curve low for all students across the board?
Sure. So our students for this particular class, this executive MBA program, they actually come from around the world. We're in Connecticut, and we had students come up from Massachusetts, which is pretty close to us, from DC, a little bit further away. We had people come from Texas. We had people come from China. So this particular program is unique in that their scheduled classes are every other week, and everything's compressed into a Friday and Saturday. So every 2 weeks they would come from all over the globe to perform the classes, and they had seminars and colloquiums and all kinds of different stuff in these jam-packed 2 days. The students' backgrounds were certainly very diverse. Some were strictly just business type people or economics type people, but we also did have some engineers, we had some chemists, we had some scientists. So it was really a big mix of different disciplines, and I think this is one of the strengths of doing life cycle assessments and teaching around life cycle thinking is if we say, we want to do a multidisciplinary approach, what are we talking about here? Are we talking about, the chemical engineer and the mechanical engineer finally sit down together? Are we talking about a truly multidisciplinary team thinking on a common platform in terms of, sustainability, sustainable design, life cycle thinking, taking people from the marketing department, from the business department, from the engineering department, the design department. This provides a good framework for them to work together. So the last part of your question was the learning curve the same for everybody? The answer to that is no. Certainly some of our more technical people got it much faster, but the range in how difficult it was for our students to start using the software was very low. We took about a 1-hour session to do a tutorial, and then we just let them loose, and they corresponded with us via email or like an online chat, and that was very minimal to answer some of their questions, but for the most part there was essentially no difficulty in them picking up the software.
Thomas, thank you so much. And we are at the top of our hour. Actually, we're a little bit past. And I do want to thank both of you for not only teaching with Sustainable Minds, but the time and effort that you took to put your stories together and share them with us. I think the learnings that you shared, both on your own and for your department, your students, were very powerful. And I really do thank you deeply, as do, I'm sure, many of the participants. They were asking the same kinds of questions. Everybody wants to know the learning curve. So with that, we're going to wrap this up. There's a quick survey as people exit to give us some feedback on this. You can request the PDF. If you'd like us to follow up with you, we can do that as well. And this webcast has been recorded. It will be posted on our blog. You'll be able to get access to it by Friday. And I'm going to thank everyone for coming and hanging out all this time, and wish everyone a great afternoon. Thank you, Thomas and Neethi.
Thank you.
Thank you very much.